All right, here we go, guys. I think we're good. Welcome to another exciting installment. Let's get right to business. And here we go, guys. Well, I guess let's hide this really quick. There we go. Nope, there we go. Okay. Quiz 34, differential equation, growth decay. I think you guys will like it. It's not that bad. Use integration to find the general solution to the differential equation. So what I would do, notice it's 2x, x minus 2. I would distribute this, guys. So 2x squared minus 4x. Already I'm making a mistake there. And then since it says dy dx, I guess you can technically just take an antiderivative there. But to be 100% correct, it's this. That's a separation of variables, and then we're going to integrate, and the antiderivative of dy is just y. So y equals 2x cubed over 3 minus 4x squared over 2, which that reduces into 2. So I'm going to erase that and put 2. And then I put a plus c there. And there it is, guys. Let's go to the next one. So the trick here, guys, is that you want the y's with the y's and the x's with the x's. Notice they paired this with a y plus 1, so keep that together. And then the x minus 2, keep that together. So times dx times y plus 1, so you're going to get y plus 1 dy equals x minus 2 dx. And then we're going to integrate. So you get y squared over 2 plus y equals x squared over 2 minus 2x plus c. And then notice that there is no 2, like none of them have fractions, none of them. So I'm going to multiply everything by 2. So I'm going to have y squared plus 2y equals x squared minus 4x. And then a constant times 2 is still a constant, so plus c. And then what I'm going to do is I'm going to move these to the left, because notice they have c's all on the right-hand side. So since they have c's on the right-hand side, here we go. Move everything to the left. So I'm going to have negative x squared plus y squared. And then I'm going to write plus 4x. And then I'm going to write plus 2y equals c. Yay, so we did the highest degrees first, and then 4x plus 2y. Why did we do it this way? Because x comes before y in the alphabet there. All right, so here we go. I'm going to multiply by dx, so we're going to keep the x plus 3 squared in the bottom here. And that's secant y, we're going to divide by secant. So we're going to, and I'm going to keep the 4 there, guys. So here's what we're going to have. dy over secant y equals 4 over x plus 3 squared dx. All right, so now 1 over secant is the same thing as cosine. So I have cosine y dy equals 4 over x plus 3 squared dx. And hopefully this is one that you can do without having to do u sub. But if you feel like you can't do this one in your head, I guess you can do u sub. You can say u equals x plus 3, du equals dx, and you get 4 over u squared. And remember, you can bring that up, so you get 4u to the negative 1, 4u to the negative 2, sorry. Then antiderivative, add 1, divide by that, so you get 4u to the negative 1, which is 4 over x plus 3, with a negative in the front. So hopefully you caught all that. If you didn't, maybe go back again and listen to it one more time. My apologies if I went really fast. Antiderivative of cosine y is sine y. Not negative, positive, because the derivative of sine is cosine y, see? Equals, and the antiderivative of that, we said a negative 4 over x plus 3. And then I'm going to put plus c. And that's it. We look for it. All right, let's go to the next one. All right, sorry guys, took a quick break there. All right, so this right here. So we're going to rewrite this. So rewrite this guy as dy dx. So we have negative 6 dy dx plus 18x squared equals 0. Move the 18x squared to the right, so negative 6 dy dx equals a negative 18x squared. Divide by negative 6, so you get dy dx equals, what's that, 3? So 3x squared. And then times dx, so then you got dy equals 3x squared dx. So now we're going to integrate. So then we're going to get y equals 3x cubed over 3. So it's just going to be x cubed plus c. So we can have any constant. So look for x cubed plus some constant, and there it is. Yay. Hopefully that made sense, guys. All right, let's go to the next one. Which of the following is different equation has the following slope field? So I know you guys love slope fields because we've been doing so many of them. So I want you guys to notice an observation. I want you guys to notice left to right. It looks like it is being affected by x, and up and down it looks like it is affected by y. So I need to have an x and a y. That one's only affected by x, is out. Possible solution, possible solution, possible solution, out. So notice that if I move left to right, I'm affected. The slopes are affected, and I move up and down, the slopes are affected. So that means it's affected by x and y. So the next thing we're gonna do, I'm looking at this one right here in particular. I'm not saying that's the answer. I'm just looking at it. If I wanted to say that this slopes, I want to find where those slopes are 0. Well, you have slopes that are 0, y equals x. I do not have slopes that are 0, y equals x. So that one's out. And let's see, so now it's between these two. So a quick way, notice the only difference is this negative here. So in quadrant 1, I need to have negative slopes. Notice that these slopes are all negative. And then notice that in quadrant 3, they're all negative. And notice that in quadrant 2, they're all positive. And notice that in quadrant 4, they're all positive. So it looks like it has to be B. I hope that made sense to you guys. All right, let's see. A certain species of virulent bacteria is being grown in a culture. It is observed that the rate of growth of the bacterial population is proportional to the number present. So that means that your dy dt is equal to proportional to the number present, ky. Yeah, all right, anyways. So now what? All right, so it says, if there are 1,000 bacteria in the initial population and the number of bacteria doubles after the first 30 minutes, how many bacteria will be present in 4 hours? Okay, you can, if you want, do this and solve for k in 4 hours, but I'm not going to do that, guys. So my initial was 1,000, so I'm going to say this. So let's see. I start with 1,000, and they tell you that after 30 minutes, it doubles. So let's see. After 30 minutes, so let's see, it doubles after 30 minutes. So after 30 minutes, I'm at 2,000. Another 30 minutes pass. 30 minutes, and I'm at 4,000. Another 30 minutes pass. 30 minutes, I'm at 8,000. Another 30 minutes pass. Oh, man. 16,000. And then another 32,000. How many hours is that already? 1, 2. Okay, so I need another 30 minutes here. So I'm at 64,000. So that's 3, and I need one more. So 2 more actually. 64,000 to 128K, and then finally 256K. So there it is. See how we did it, guys? We just found out how many times it doubled. It doubled 1, 2, 3, 4, 5, 6, 7, 8. Well, yeah, that's how many doubling time intervals there are in 4 hours. So 4 hours divided by 30 minutes is going to be 8, or 0.5. So 4 hours divided by 0.5 is 8 times. So 8 iterations. Iterations of doubling. Hopefully that made sense. I guess there is another way to do it. Here's the other way that you could have done it, guys. You could have done it this way. So maybe this is easier. You could say let's see, it doubles, so 1,000 times 2 raised to the kt. And your k in this case, let's see, it's going to double every, so the t is the time, and it doubles every 30 minutes. So we need to figure out how many iterations there are. So it's going to be, we already said there's 8 iterations, so it's going to be 2 to the power 8. So 1,000 times 2 to the power 8, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, 128 times 2 is 256. So there it is, 256,000. So maybe this is the better route, better, and this is the okay route. So where the number 8 is how many iterations we have. Iterations, that is that number. All right, let's keep going. It says, in a bacteria growing experiment, biologists observed that the number of bacteria in a certain culture triples, so it triples every 2 hours. After 8 hours, it is estimated that there are 2 million bacteria in the culture. How many bacteria are present initially? Okay, so this is going backwards, guys. Going backwards. All right, so how many iterations are there in 8 hours? Well, let's see, 2, 4, 6, 8. So there's 4 iterations of tripling in 8 hours. So it tripled, so let's see, 3 to the power 4. So 3 times 3 is 9. I'm just going to use the calculator here. 3 to the power 4. So it's 81. So it got 81 times bigger in 8 hours. 81 times bigger in 8 hours. So if I got 81 times bigger, take the 2 million and divide by 81. So 2 million, 1, 2, 3, 4, 5, 6, divided by 81. Okay, so 2 million, 1, 2, 3, 6, divided by 81 gave me 24,691.4. So there it is. All right, guys, took a little break there again. All right, real quick. On this one here, it says, according to the Bureau of the Census, the population of the United States in 1990 was approximately 249. And in 2000, it was 281. Use this information to predict the population for 2020. All right, so the population growth is based off of how many people are present. So because of this, I'm able to write y equals c e to the kt. And I'm going to use this as my initial. So I'm going to say this is my time equals 0. So if time equals 0 in 1990, that means my c must be 249. So here's my equation, 249 e to the kt. So I'm going to solve for k first. Solve for k. So I'm going to use this one here, 281 at 2000. So that is t equals 10. So I'm going to rewrite 281 equals 249 e to the 10k. So I'm going to divide by 249, divide by 249, and then ln and ln. So I'm going to have ln of 281 over 249 equals 10k. I did ln on both sides, guys. And I'm going to divide by 10, and I'm going to store that. So I got k equals, and let me see what I got. So I'm going to do, where's my ln on this guy? ln of 281 divided by 249, close, and I'm going to divide that by 10, and I got k is equal to 0.01209. I'm storing that to a. So now every time you see an a, that's that k value that I stored. All right, so let me store that to a, alpha a. Done. Okay, so now I'm going to go ahead and solve for when the population is 2020. So my population of 2020 is 249 e to the a times, let's see, if I'm at 2020, that's 20 years more than 2000. So that's going to be to the 30. So that is t equals 2020. So I'm just going to type that in, 249 e raised to the alpha a here, alpha a times 30, and I'm going to push enter, and I get 357.866. Y equals 357.866. So 358. All right, hopefully that made sense. A 100-liter tank initially full of water develops a leak at the bottom. Given that 30% of the water leaks out every 5 minutes, find the amount of water left in the tank in 10 minutes. So that's 2 iterations. Two iterations of 5 mins. So let's see, the water. Okay, find the amount of water left. So if this is how much goes out, I have 70% of the water in. Hopefully that made sense. So let's see, the initial amount is 100. So 100 times 0.70, and there's how many iterations? 2. So there it is. So 0.70 times 2. So obviously it's going to be 4.49, right? 0.7 squared. Yeah, so 100 times 0.49, and you get 49. There it is, guys. All right, let's keep going. 2 years ago, there were 7 grams of radioactive substance. Now there are 6 grams. How much will remain 2 years from now? Okay, so 2 years ago, we're going to say that was the initial time. So t equals 0. There was 7 grams. And then t equals 2. There is now, it says 6 grams. So solve for k. Solve for k. So because the amount present depends on how much you have or you had, this is the rate of change. The rate of change depends on the amount that you have. So I'm going to use this, so I can say y equals c e to the kt. I'm going to solve for k. So I'm going to write the initial amount is 7. Y equals 7 e to the 2k. So, and then the amount that I have after 2 years is 6. So 6 equals, okay, well I already wrote it. There's no reason to write it again. Divide by 7, divide by 7. So 6/7 equals e to the 2k. I'm going to write ln on both sides because we're trying to solve for k. So ln of 6/7 equals 2k. Divide by 2, divide by 2. So I have my k value is, let's see, ln of 6/7 divided by 2. And I get k value of negative 0.077075. You should not be confused as to why it's negative because there's a decay. So that's why I'm going to have a negative exponent. And I'm going to save that to a, guys. So I'm just going to store that. Store alpha a. All right. So now here, every time you see the letter a, I'm using that. So here we go. How much do I have in 2 years from now? So that means t equals 4. T equals 4 question mark. So I'm going to write y equals the initial amount, 7, e to the 4a. So 7 times e, there we go, to the 4 alpha a. And I get 5.14286 grams. There it is, guys. All right, the half-life of radium-226 is 620 years, so that's your half-life. How long will it take for the original amount to be reduced by 60%? All right, so I'm going to solve for k again. Solve for k. I'm going to change it up to red, guys. So so it's taking me, for me to have the amount, so why not e to the K, and it takes 1,620 years. Man, sorry guys, it's getting late, and it's been one of those 16-hour days here, because I got here at, yeah, anyways, I guess, yeah, 12, 13, 14-hour day, 15-hour, yeah, okay, anyways, let's keep going. Y naughts cancel out, ln, so ln of 0.5 equals K times 1620 divided by 1620 divided by 1620. And if you would have Googled Half-Life, maybe you would have found something like negative ln2 over 1620 would give you your K value, but no big deal. We just derived it here. So I get, let's see, ln 0.5, which is the same thing as negative ln2, divided by 1620. I get negative 0.000428. Sorry, guys. 0.000428. I'm going to store that to A. So store alpha A. All right, so there it is. So now I'm ready. How long will it take for the original amount to be reduced by 60%? If I reduce it by 60%, that means I have 40% left. So that's what I'm going to do. I'm going to say 0.4 y naught equals y naught e to the a t. Solve for t. Solve for t. So the y naughts cancel out. Then I'm going to do ln. So ln of 0.4 equals, if I do ln, you get at. And I'm just going to divide by a. So my time is, and I'm just going to type in again, so ln of 0.4 divided by alpha a. And I get 2141.52. Was that the last one? Oh, that was the last one, guys. Happy face, yay. I hope you enjoyed that one, guys. If you have any questions, let me know. Put it in the comments maybe. If you find any errors, let me know as well. And I hope you guys enjoyed that one. All right, later guys. Bye.